Hey everyone, concerning for polynomials, we have a polynomial with imaginary coefficients. So the roots of the equation, z cubed plus ki z squared plus 5z plus 3ki have roots z1, z2, z3. And given that z1, one of the roots, is I, find the value of the real number k. So I think it's quite simple, so simply substitute z equals to I and then solve from there. Now, please don't substitute k equals to I. That would be, well, first it's wrong, secondly it's quite hilarious. K is a constant, alright, so don't make that mistake. So we have minus I minus ki plus 5I plus 3ki equals to 0. So from here I think it's quite obvious. For I equals to minus 2ki, you can do 2ki equals to minus 4i, whatever it is, k equals to minus 2. Therefore, value of k equals to minus 2. Now, because this is a polynomial with imaginary coefficients, we cannot use the conjugate root theorem and say that minus I is definitely a root to the equation z cubed minus 2i z squared plus 5z minus 6i. Because, well, you don't have all real coefficients, right? We have some imaginary coefficients, so the minus I may or may not be a root. And because of this uncertainty, we cannot assume that it is a root. Alright, unlike in a polynomial with all real coefficients, the conjugate is definitely 100% a root. So instead, we're just gonna do our normal factorization. So we have z minus I. Alright, so part 2, we just basically want to find the roots to z2 and z3. And with the taking note that the argument of z2 is less than the argument of z3. And quite rare, but we want to express the answer in RI theta. So we have z minus I as a factor, same thing, coefficient of z cubed is 1, so we have z squared, coefficient of the constant is minus 6i, so we have plus 6. So we just focus on either z squared or z. If you want to focus on z, we have plus 6z, we have an extra z, extra 1z, so to get rid of the extra 1z, it'll be minus iz. Alternatively, you can just look at it this way, minus iaz plus 6z equals to 5z, iaz equals to z, then ia equals to 1, a equals to minus I. Alternatively, the other way to look at z squared. If you were to look at z squared, you notice that we have iz times z first, right? So this imaginary z times this, and this one times this. Minus iz squared, we are short of minus iz squared, so we need another minus iz squared, so it'll be minus iz. Whatever it is, to find z2 and z3, we'll be using the quadratic formula. So we have minus b, I, plus minus b squared, minus I squared is minus 1, minus 4ac, minus 24, over 2. I plus minus 5i over 2, so we then have 3i or minus 2i. And you notice that, hey, there's no conjugate root pair, right? I, there's no minus I. 3i, there's no minus 3i. Minus 2i has no plus 2i. So very simply, you can change this to RI theta form. You know that I is just the argument of pi over 2. EI pi over 2. Minus 2i, so obviously you can have r being a negative number, so it'll be 2. Minus I would be in the negative x, or rather negative y region, or negative imaginary region, so we have the argument of EI minus pi over 2. So I think it's quite obvious. z2 equals to 2EI minus pi over 2, and z3 equals to 3EI pi over 2. So there we have it, how to solve polynomials with complex coefficients or imaginary coefficients, and I'll see you guys in the next question type.